Hello friends, in this video I will illustrate how you can analyze motion on a banked road, and in this problem we will find maximum speed on a bank road. So problem says a circular road of radius 1 kilometer is banked at an angle of 45 degree to the horizontal on the curved path. Find the maximum safe turning speed for a car of mass 2000 kg on this road if the friction coefficient between road and tires is 0.5. So let us plan this problem. So what we have in this case, we have a mass m and this is the car, and this is moving on a circular track and radius of circular track is given. So this radius is r. And this is the vehicle, the car we have, and this is basically moving in this circular track. And the radius of this is given r. What other things are given? So we have been given mass of this object, that is 2000 kg, radius is 1 kilometer, friction coefficient is given, and banking angle is given. And what we have to find? We have to find maximum velocity. So let's see how will you do this problem. So what we have to do first is we have to see a cross section. So if you cut a cross section here, how this will look like. So in this case, it will look something like this. So if you cut a cross section, you have a horizontal road, and then this is connecting to this. So this is the vertical portion of the road. Now here your car. So this is your car. So now what are the forces that is acting on this car? You see, one force is the weight that will act in the downward direction, and this is simply mg. And there will be a normal reaction on this car. This will act like this. And this car has a tendency to go out. So it will have a tendency to slip in the outward direction. So it is a tendency to go out. So this means friction force on this car will act in opposite direction. So we will have friction force. This is acting along this direction. So friction force on this will act in this direction. So let's call this friction force F. And this car is basically moving in a horizontal circle, and let's say radius is given. So this radius is r. So this horizontal radius is given r. Now you have to analyze this situation. So how will you solve this problem? So you write two equations. One is for balancing of the vertical component of forces. Another is for writing the equation of motion, since this is moving in a circle. So if you write these two equations, you should be able to solve this problem. So let us try to solve, and I will see you in a while. Okay, so let us try to solve this problem. So you see, so normal reaction will have one component in this direction, that is the vertical direction. You will have one component of normal reaction in this direction, that is the vertical component. Another component will be in this direction. And this angle is given in the problem. So this angle is theta. So this angle will also be theta, because angle between lines is equals to angle between perpendiculars. So this will be, since this is n, so this will be n cos theta, and this will be n sin theta, and this is mg. Now friction force, so friction force will have two components. One component is downward direction. What will this value? So this angle is 90 minus theta, so this will be f cos 90 minus theta, that is simply f sin theta. Now friction force will have another component in this direction, and this will be f cos theta. So in this direction you will have f cos theta. Now let us write equation. So if I write equation in the vertical direction, we can write n cos theta is equals to mg plus f sin theta. And friction force is nothing but mu times n. So we can also write n cos theta is equals to mg plus mu times n sin theta. So if I rearrange, I can take n common. So this will be cos theta minus mu sin theta is equals to mg. So from here I can write n, which is equals to mg by cos theta minus mu sin theta. And theta is nothing but 45 degrees. So sin theta is equals to cos theta, which is equals to 1 by root 2. So we will have mg divided by 1 by root 2 minus mu times 1 by root 2. So normal reaction will be root 2 will go on the top. So root 2 mg, this divided by 1 minus mu. So this is my normal reaction. Now we have to find the maximum velocity. So we have to write one more equation, that is equation of motion in circle. So forces towards the center, so that is force in the radial direction is equals to mass into acceleration in the radial direction. And in the radial direction we have force. One force is n sin theta, another force is f cos theta. So we will have n sin theta plus f cos theta is equals to mv square by r. Because this is the maximum velocity. This force will provide, so this force will provide a value of velocity that will basically result in the maximum. So this is the maximum velocity. So this force can provide a maximum velocity for v. You cannot have more than this. If you have more than that, then what will happen? This force is not sufficient. In that case, this will skid. So let us write n sin theta, and f is nothing but mu times n, and this is cos theta is equals to mv square by r. If I take n common, so it will have n sin theta plus mu cos theta is equals to mv square by r. Now I know my value for sin theta and cos theta, so this will be an n I also know. So I can plug in from equation 1. So n is nothing but root 2 mg, and this divided by 1 minus mu, and then this will be sin theta is equals to 1 by root 2 plus mu cos theta is also 1 by root 2. This is equals to mv square by r. Now if you solve this, so you will have root 2 mg 1 minus mu, and this will be 1 plus mu divided by root 2, and this is equals to mv square by r. So now I can write here. So basically this root 2 cancels out, m cancels out. So what we will have v square is equals to rg 1 plus mu divided by 1 minus mu, and mu is nothing but 0.5. So v square is equals to rg 1.5 divided by 0.5. So this is v square is equals to 3 rg. v is equals to under root 3 rg. So let us plug the values. So in this question it is given that radius is 1 kilometer, that is 1000 meter, and g is 10 meter per second square. So if you calculate, this will turn out to be 100 root 3 meter per second. Now question for you. So in this problem we said we have a maximum velocity. So what is this problem? So we have this plane and this is here, and my vehicle is moving something like this. So we said friction force will, so this vehicle has a tendency to move in the outward direction. So this is trying to skid outward. Then friction force will be acting in this direction. So friction force in this case is acting in this direction. That is towards the center of the circle. Now for this case you got a maximum design velocity. Now the question is, what will be the minimum design velocity and how will you calculate that? In that case, in which direction friction force will be acting and in which direction your vehicle has a tendency to move, tendency to skid. So let us discuss all these things in the comment box and I will see you in the next video. I hope you enjoyed this video. If you enjoy, please share and subscribe to my channel. Thank you.